In this episode, we will see how to make a resource manager. Resource as in-game resource, like Idleons. So we will make a class that we will use to help managing that resource. This class will have two main points, two key features, which are the public entry points to create or consume resources, and signals to signal what's happening so that if some elements of the game are relying on that resource changing, they can know. The process of making this resource manager is going to be very similar to making the clock. We'll create a gray node, which is going to be Idleon's manager. We'll save it as a singleton, like this, manager, and we'll be able to start working with it. So first we do need to create the script and make it an actual singleton. So this class is going to be communicating directly with the data from the game, and in fact it's going to make sure that other elements don't have to do it. So because we will be using this a lot, we will create a data object taken from the game, of course. Now that we have that game data, we can start thinking about the entry points we want to create. So the first one is going to be getting the information. So we will just have get Idleons. This function is going to be very simple. It will just return the amount of Idleons available at the current time. So we'll have data.resources, Idleons, and this is exactly what we will be returning. So we will return that. This is the simplest entry point. The second entry point that we can create is create Idleons. So here we're going to have create Idleons. We can kind of get rid of those Idleons suffixes because it is very much implied by the class itself, Idleons manager. But I don't know, I like it like this. So we'll have a quantity with the base as an integer, and it will return an error. So we never used error, I believe, so you will see it's quite easy to use. So error is a native type of gdscript that you do use to say if a process succeeded or if it failed. And this is exactly what we will be doing. So here we'll just create this return OK. OK is one of the values of this error type here, and there are others, but basically we only use failed and OK when we create it by ourselves. So this will return OK if it all goes fine. When it all goes fine, what we will do is just have this data.resources.Idleons increased by the quantity of that we have inferred as an argument. Now, it can go wrong when the quantity is equal to 0 or when it is negative. In the situation, we don't want to trigger the creation of Idleons and say, well, something went wrong. So if quantity is inferior or equal to 0, then we will just return fail, like this. So here we have the first entry point, which is creating Idleons. Third entry point that we will create is consume Idleons. So this one, again, we use a quantity, which is an integer, and I'm gonna let it like this at the moment. So also it will return an error. So if it all goes fine, we will return OK. But this one will be trying to consume Idleons, and we will have different states, right? Can we consume it? Can we not? For this one, when it goes fine, we have the data resources Idleons decreased by the quantity, and that's pretty much it. We return OK. We have two scenarios where it can fail. The first one is exactly like the previous one. If the quantity is inferior, I will leave equal as OK. So if it is strictly inferior to 0, we will return fail. I want to leave 0 OK in case that we do want to have free things, like the cost is so low that it becomes free, then yes, you can get it for free. There's no problem with that. The second case I want to return a failed error is when the quantity is actually superior to get Idleons. Well, let's have data the resources .idleons. When it is the case, when the quantity is superior, then we can't spend those Idleons because they are actually, it costs too much, right? That's pretty much it. This is what we will be creating for the first entry point. Now we have to take care of the script actually signaling what is happening. So we can create a few signals, like at the moment we will just have Idleons updated. That's the first signal we will be working with. Later, I just want to say that we can create more. I will just leave those as comments, but I'm not going to use those yet. So we'll have signal Idleons created or signal Idleons consumed. This can be useful when you have quests or achievements or statistic trackers, basically. So anyway, here we're going to have that the amount of Idleons has been updated. There we go. So technically, we do want to fire the signal in those two situations when we consume and create Idleons. So here we'll have Idleons updated, emitted, and exactly the same. Now that this resource manager is working, I believe, we can add it to our game. Let's actually create a node that's going to be the category for the resources. So here we're going to have this resources node. And in there we can just get our Idleons manager, and there we go. We'll have this singleton ready to use by the game as soon as it is loaded. So what we can do from there is update the first scene we have created so that it does use this new create Idleon method, and at the same time watch the signal for the label to update, and that is the important part. First, let's take care of this Idleon creation here. We have data resource.idleons increased by 5, so we're going to change that, and instead of directly editing data, we will have the Idleons manager reference, and we will create 5 Idleons. So we can get rid of this data reference, okay. And because of that, we have to update how the label is fetching the data as well. So here we will have the Idleon manager and get Idleons. Okay. Lastly, we can take care of this process method here. So this process method, we can get rid of it, but we need to call on the update label. For this, we will just create a watching method. So on Idleons updated, we will be watching that. So here, we just want to update the label. Of course, we do need to bind this signal. So in the ready function, when the scene is first loaded, we want the Idleon signal Idleons updated to be connected to our new method. Okay, so now we are correctly watching the Idleon update. So we can try just to run the game and see that it all works exactly as before, except that when we have unlocked the generator and come back here, the label doesn't update anymore because the generator isn't using the new thing we have created, manager. So we can go in our Idleon manager and make sure that when we generate, actually it's fine, I opened it at the right position, but yeah, when we generate, instead of editing game data, we go with using the create method. There we go. There it is. We can check if we do use this game data resource somewhere else. Seems fine. We actually can go with game.ref.data.resource and we have no match. So it is not used in the generator anymore. So that's cool. We can check if it worked by just going in the game. And there we go, unlocking this. And we generate the Idleons properly. But again, you may have noticed that when we unlocked the generator, it didn't move here, because when we purchase, we actually don't consume Idleons with the manager. So again, we can change that very quickly. We just go in our script, and yep, here we have two things. We are just trying to see that if the game data resource Idleon is inferior to 25, we return. So this technically we can get rid of because it's in the consume method now. And here we are consuming the Idleons. So what we can do is Idleons manager consume Idleons, and here we have the quantity, which is cost. But it returns an error. Okay, so what we do here is that we will store this error. So we have this error, which we will do store as a result of that. Okay. And from there, we will see, based on this result, if we keep going or not. So if we have an error, so it works like this. If the error is positive, then it means that it failed. So if it is positive, then we return because something failed. However, if there's no error, then we keep going. That's pretty much what happens here. Let's actually reformat this so that it's using this single line as well. And yeah, that's pretty much it. We don't use game data resource here as well. So we can, again, go back to our game and see that we have fully implemented this new manager. We can unlock this, lose the Idleons, and have the generator start working. And there we go. I was going pretty fast in there because, yeah, I can make very long videos on topics which are often not very interesting, like refactoring old code, which I was doing right here. So anyway, I hope that was clear enough and not too fast. If there are some aspects which were not very clear, don't worry too much, because here I was just presenting the manager, but I will actually be doing a lot more of those. So you will have me explaining it differently, because I will be doing in some optional videos new resources, because from there the game will start to take another turn, and I'm gonna go away from this generic resource, which is the Idleon, and start creating something which makes a little bit more sense, right? So we will see in the future episodes exactly where we will be going with that. So that's it for me. I will leave you there, and I will see you in one of the next episodes of your choice.